All right, guys, in this video, I'm going to go over some proofs with these triangle congruence theorems. Now, before we get started with that, I wanted to go over kind of like 5 things to put in this box here to help us with these different proofs. So I'm going to start with the first one, which a few of you have already used before. Let's start with something called the reflexive property of congruence. And you'll see this happen a couple of times in the examples here. All right, so this could be a segment or an angle that is congruent to itself. So right now it may not kind of make sense until we do it within a proof, but the example that I'm thinking of is you could say AB is congruent to segment AB. All right, what you're going to find out is this comes up a lot when these triangles share a side or share an angle. And so we have to actually write down that they are congruent, even though, yes, you know that they're the same because they share it. But we still have to take that line to write this property. Okay, the next thing is the definition of perpendicular lines, which we've talked about a lot, especially in our last unit. All right, so for the definition of perpendicular lines, we write if lines are perpendicular, then they form right angles. Something that you already know, but just making sure we formally define it before we use it here in a couple examples. Another one is all right angles are congruent. All right, that hopefully doesn't surprise you. And then 2 more, we have the definition of right triangles. All right, and this is if a triangle has a right angle, then it is a right triangle. Again, something that you already know. Okay, and the last one, which is an acronym we're going to use a lot in these proofs, is CPCTC, which is corresponding parts of congruent triangles are congruent. All right, so when you see this acronym, that's what we're referring to. Okay, so in this first example, we are going to take these 2 congruent triangles, ABC, and triangle CDA, and we are going to mark on the diagram everything that's the same, as well as listing that all out. So I'm going to start by labeling segment DC and segment BA are going to be congruent to each other. So I'm going to list that here. So DC is congruent to segment BA. Then I'm going to do, let's do segment AD is congruent to segment BC. Okay, and then my last one, you can see that they actually share this. So this is AC is congruent to CA, or you could say is congruent to AC. They're actually the same, so there's no issues there. All right, now in terms of the angles, all right, the way I want to label the angles here is I have my first angle, I'll use just angle D. There we go. And then that's going to be congruent if you flip these triangles in your mind to be on top of each other. That's going to be congruent to angle B. So angle D is congruent to angle B. All right, then I'm going to look at angle DAC is congruent to angle BCA. So angle DAC is congruent to angle BCA. And last but not least, I also have the third angle here, angle BAC is congruent to angle DCA. So angle DCA is congruent to angle BAC. All right, so that's everything labeled as well as put here in terms of their congruent, listing it out. Again, we've done this many times in the first unit, right? Segments, you could label like that first one I labeled DC, you could label that CD. My angles, you have lots of different ways to name the angles. Just make sure that the middle letter is going to be the vertex of that angle. So again, it might be different if you did this on your own, but just be sure that it might actually be the same, even if it looks different. Okay, I'm gonna let you guys practice number 1 on your own and number 2 on your own. I'm gonna do the next proof, number 3, in this video. Okay, so in number 3, a lot of this stuff is given to us, which is nice. Not only like multiple givens, there's 3 of them, but also lots of information in the statements and the reasons. So kind of trying to help you start this off. So I'm gonna label some stuff on the actual figure here. They're telling us that BA, that segment, is perpendicular to AC. So this means that I'm going to have a right angle there, which we're going to prove here in a moment. And then it also says segment CD and DB are perpendicular. So I'm going to go ahead and do that there. And then again, it says AB is congruent to DC. So AB is congruent to DC. So just marking those for us there. All right, so you can see the 2 givens are written. The next thing I'm going to write for my statement is going to be that angle A and angle D are right angles. All right, and this is from what we talked about at the beginning of the video, is that is the definition of perpendicular lines, right? We said that if lines are perpendicular, then they form right angles. Oops, not that. Perpendicular lines. There we go. All right, and I label those right angles in pink. All right, the next thing we're going to say is that these 2 triangles are actually right triangles. So triangle ABC and triangle DCB are right triangles. And again, something that we wrote earlier, we wrote that if a triangle has a right angle, then it is a right triangle. That was the definition of right triangles. Okay, now the next thing is actually that reflexive property we talked about at the very beginning, where it says segment CB is congruent to segment CB. All right, we are proving that, so I'll mark it on the figure. We are proving that this is going to be used as the same for both of these triangles, right? They share it, which is obvious. So we know that we need to prove that it's the same, or actually state that it's the same. So this is that reflexive property of congruence. So reflexive property of congruence. All right, now we have another given here, which the one that we haven't used yet is this segment AB. Even though I've marked it, segment AB is congruent to segment DC. Let me try this again. There we go. All right, so that's our last given. And now our proof here, we're trying to prove triangle ABC and triangle DCB are congruent. So the idea here is that if you were to take one of them, whichever one you want, and kind of manipulate it or rotate it in your mind, flip it and rotate it, to line it up with the other triangle that you left alone, right, you should see that one of the properties we discussed last week with right triangles, or triangle congruence, I should say, is the hypotenuse leg theorem. So saying that if 2 right triangles have a leg that's the same or congruent, and they also have the same hypotenuse, then the triangles are congruent. All right, that's what we have here. So I'm going to put the hypotenuse leg theorem of congruence, of triangle congruence. All right, that's proving that these 2 triangles are the same. All right, so that's kind of the way that we're going to go about doing these proofs with these triangles. Okay, I'm going to skip 4, but check back for 4. There's a key on Canvas. You can take a look at that. Let's try 5. The reason I wanted to try 5 is because you'll notice that we don't have anything written in our proof. We have to kind of just do this from scratch. All right, so the nice thing is you've done enough of these proofs with our perpendicular and parallel lines that you know that we're going to start with the givens. So I see BC, that segment, is congruent to segment DA. So that is a given. And it's actually already marked on the figure, which is nice. Then they're telling us that segment BC, the second given, is parallel to segment DA. So that's another given. Okay, now I know you can do this if you want, it's up to you, but I know I have to prove that triangle ABC is congruent to triangle CDA. So I'm gonna go ahead and fill that in, but you don't have to do that now, you can wait. So I need to figure out how to get there. Well, when I look at this, I notice that they told me these two segments are parallel. And if you guys remember from the previous unit, right, we know that if there's a transversal, which I see segment AC is a transversal between those parallel segments, that we can use some of the theorems that we know to prove some congruence. So I'm going to prove angle BCA is congruent to angle DAC. So I'll mark that here. All right, so BCA is here, and then DAC is there. I'm hoping you recognize that those are alternate interior angles. So this is if lines are parallel, and I recognize that they're segments, then alternate interior angles are congruent. All right, hopefully you remember that from our previous unit. So now we've proven that those are the same. All right, now what we're going to do is we're going to use the fact that they share this segment CA or AC and use that reflective property we talked about before. So this is segment AC is congruent to segment AC, or you could write AC is congruent to CA. It doesn't matter, right? Those are the same thing. So this is that reflexive property of congruence. Okay, and then finally, now that we have that, if you again manipulate one of them, rotate them in your mind to line up the angles and the sides, all right, you would see that we have side, angle, side in terms of our triangle congruence. So if we know that corresponding sides and then the included angle are congruent as well, then we know that everything about these triangles are the same. So I'm going to write for my proof here is side, angle, side, triangle congruence. All right, which is what we talked about in part 1. Okay, so that's it for number 5. That's how we do that proof. I'm going to do number 6 on this video, and then I'm going to be finished. Again, please feel free to check the key on Canvas to look at the ones that I did not do. All right, so we want to find the measures of the angles in the triangle. All right, so first we need to figure out what X and Y are. First thing I notice is it's an isosceles triangle, right? We have these two tick marks here. So that tells me that this angle that's opposite one of those sides and this angle opposite the other side are going to be the same. So X plus Y is going to be equal to 2Y minus 10. I also know from our understanding of triangles is that all three of these, if you add them together, should equal 180 degrees. Okay, so we know that's going to be true. All right, and because we have two different equations that are kind of linked here, this is what is known as a system of equations, which you would have seen in Algebra 1. What I'm going to do is I'm going to take this first one that I wrote, the X plus Y equals 2Y minus 10, and I'm just going to isolate for X. So I'm going to move this Y to the other side. And when I do that, I get X by itself. 2Y minus Y is 1Y. Bring down the minus 10. And so what I'm going to do is I'm going to rewrite my second equation, so this one here, but because now I know that X is equal to Y minus 10, wherever I see X right here, I'm going to replace that with Y minus 10. And that way I only have Y's. This is called substitution. And I'll be able to solve for Y. Okay, so again, I'm replacing this X with the Y minus 10. I'm going to put it in parentheses because you should always use parentheses when you substitute. But what you'll notice is that there's nothing being distributed, so you can just take those off and combine like terms. So the 4Y, the Y, the Y, the 2Y. So that's going to be 4Y, 5Y, 6Y, 8Y. I see minus 10, that's minus 20. move over that minus 20 with adding 20, all right, and you get 200. All right, so when I'm trying to figure out what y is equal to, I'm going to do 200 divided by 8, which is going to give me 25. Okay, now we know, based on what we just did earlier in the problem, that x is equal to y minus 10. So I can do x equals 25 minus 10 to get x equals 15. Now that's not what the question is asking. It wants to find the measures of the angles. So I'm just going to go back here and plug in the stuff that I figured out, x and y, to figure out these angles. So that's going to be 100. That's 100 degrees. And then you can probably figure this out without plugging it in, but I'll go and plug it in. 15 plus 25, plugging this in is 2 times 25 minus 10. Again, because it's isosceles and it has to add to 180, you have 80 degrees left between those other two angles, and they have to be equal. So both of these are going to be 40 degrees. All right, which matches the math when we plug them in. All right, so that's number 6. Again, don't really stress too much about that. That's just kind of pulling in some stuff from Algebra 1 and your understanding of triangles and angles. All right, again, check the key on Canvas for any questions you have. Come see me in office hours. Good luck.